So OSPF area concept we discussed. Okay. In this, in this we then discussed about the OSPF. What? OSPF types of areas, right or not? Types of OSPF areas. Okay. So we have seen there are lots of type of areas in the OSPF. Okay. First one is what? The backbone area. Which one, dear? Backbone area. Backbone area. Okay. Backbone area. Backbone area is the central focal area or centralized area for all the areas. Basically, this backbone area is the centralized area for the same. Centralized area that will also holds much more information as compared to other, right? Central area, and that must be connected to all of the other areas, right? Now, except of these, we have many types of areas like stub areas, right? Totally stub, right? Totally stub areas, not so stubby area, okay? And total not so stubby areas. So we have four types of areas, and that are really important because if you will appear in any interview regarding the uh, OSPF, it will it is possibility that most of the question will be asked from the area concept. Clear? So that is why we are going to cover up the area concept over here. Okay. So how many types of areas are there? Four types of areas: stub area, totally stub, not so stubby area, and total NSSA. Total not so stubby areas. Okay. Let us assume, dear, we have two areas. Okay. This is area 0. Okay. And this is area 1. This is area 0 and this is our area 1, right? In between them, in between them, when the data will be forwarded, when the data will be forwarded, there will be a common router in between these two. Let us assume this is R1 is the common router here. Some routers are available here like R2, R3, okay, and here it is R4, right? And it may be possible some routers are available over here also like R5, okay, R6, okay, and R7 and R8. So let us assume these are the routers available in between these two. Okay. Now what is happened here? What is happened? When the routers will forward the data within the same areas, when the data will be forwarded, so this router is sharing the data to this side, this, right? When the routers are exchanging the data in between the same routers, so that will be exchanged on the behalf of what? LSA 1 and LSA 2, right? Same will be happen on this side. Routers are sharing the data. This router is sharing the data. This router is sharing the data, right? This router is sharing the data within the same area. This is also called LSA1 and LSA2 type, right? LSA1 and LSA2 type. Clear? Now, let us assume that this router, let me change the color. Okay. This router will forward the data to this router, right? And this router is forwarding the data in between two different areas. What? Let us assume the data is forwarded in between two areas. When the data will be forwarded or exchanged in between the areas, in between the two areas. So which type of LSC is this, dear? Hello.
It's LSC 3, sir.
Yes, dear. Which type of LSA will be there? LSA
It's
type
trees.
3, right? So this will be
Yes.
LSA type 3. LSA type 3. Okay. Let us assume that this router is connected to the ISP. What? ISP. So it will receive some external routes, right or not? It will receive some external routes. Let me change the color. Okay. So in this scenario, okay. So let us assume that the router is receiving any update from the external, exchanging the update from external. Okay. Now this router will forward this update to this router, right? And this area border router will forward the routes throughout, right or not? But these these type of LSAs, when forwarded from the ISP or other router, other protocol like BGP, right? It is accepting the data from BGP protocol because if it is connected with ISP, so data will be received in form of what? LSA, LSA type 4 and 5. LSA type 4 and 5 when the LSAs will be received from the other networks, other other protocols from the external, that is called LSA 4 and 5. Clear? Is this clear, dear?
Yes, sir. Clear.
Y- Yeah. So let us assume that LSAs will be forwarded from this area to this area, right? So it will be forwarded through first area. Which one? Let us assume this is area 0 and this one is area 1. This one is area 1. So it will be forwarded from area 0 to area 1 and this was LSA type 4 and 5. Okay, LSA 4 and LSA 5, right? Coming from area 0, forwarded to area 1. Now, when this external routes will be received, increase size of table, right or not? They will increase the size of table. They are coming from external, right or not? In that scenario, if I want to block this LSA 4 and LSA 5 coming from the ABR, this is our ABR, right or not? Area border router. We will configure the stub area on this side. What? The stub area. Now, what is the meaning of that? That these number of routes will be converted to O star. O star. What is the meaning of O star? That is means default route. That will be converted to default route, or we can say when the data will be forwarded here 0.0.0 slash 0 in form of what? Default route. The subnet mask according to the default route, this is the network for default route and this is the subnet mask of default route, right or not? So the routes will be converted to the default route and will be blocked at the ABR. So ABR will block these routes and convert into default route, right or not? This is called this is called the stub area, right? Any confusion, dear?
Till now
Hello.
it is okay, sir.
Yeah. And if I talk about the not so stubby area, which one? Not so not so stubby area, NSSA, that is entirely a different concept. But what about the total stub area? What is the meaning of total stub? Totally stub area. We can see that along with LSA type 4 and 5, LSA type 3 will be forwarded, right? And will also increasing the table over here. So what we will do in this type of scenario, we will do the total stub. The totally stub area will also block the LSA type 3 and will convert these to default route. LSA type 4 and 5 will be blocked, 3 will be blocked. In case of total stub, on when there is only stub in stub, only LSA 4 and 5 will be blocked. But in case of totally stub, LSA 3 will be blocked. Right? Now, any confusion with the total stub area, dear?
Sir, one question is that if the area router converts the LSA into the default routes,
Default route. Yes, dear.
then default route means to communicate with any network, right? Any
Yeah.
network or
Yes, dear. Actually, this is what we are doing to reduce the tables actually. If there will be lots of routes in the table, that will create the issue, right? So to reduce the table, we are doing all that. There's only one reason to do this. Okay.
no, sir. Like for example, from external links, for example, we are getting the IP addresses of Facebook and Google.com as well.
Yes, dear.
But if
Yeah, dear.
but
If
if we use the stub area in the converted in default routes, then default route also can communicate with Google
yeah,
and Facebook.
dear, what is the meaning of default route basically? The default route means the default route means allow. What is the meaning of this one basically? Let me explain you. What is the meaning of this one? When there is network, the network is what? 0.0.0.0 and mask. Subnet mask is also 0.0.0.0. This means starting from 0.0.0.0 and end up to 255.255.255.255, all IP version 4. What is the meaning of default route? All IP version 4 accepted. Okay. Can you hold on for a minute, dear? I'm getting a call from office. Okay, just a minute. Let me mute just for a second. Hello. So the meaning of stub area is what? To accept all the routes and convert them to default route, right? But secondary, you're asking that I want to receive some specific routes, right or not? Specific routes.
No,
Like,
sir, I am not asking. I'm asking that stub area will convert the LSA into default routes,
yeah,
and the
convert yeah, default route will
default
accept all the IP addresses.
all the
Ac-
IPs. Then what is the reason behind to of using this stub area?
Yeah,
Or I think it's
to to reduce the tables. That is only the reason to do that. Because in external there can be number of routes, right or not? So to reduce the table, we are doing this.
so the
Then
number of routes. All the routes will come in between the 0.0 and
yeah,
255.255.
here as I told you that it is complete IP version 4. The complete IP version 4 means all IP address in universe. In IP version 4 basically. In universe. In the world will be accepted. Right? The meaning of default route is this. Okay. So now let's move toward the configuration of stub area dear. In case of stub area, any confusion dear?
So go ahead. We'll next
Still,
after it.
still any confusion?
Not now, sir. We'll question after it once we explain the full configuration.
Yeah, dear. So let's move forward to the to the GNS3. Okay, this is stub area. Okay, so dear, let us assume we have a router over here, a router over here. Okay, and that is connected to two routers in a network. Okay, here. Okay, and the next one, a router is also available here. This one. Okay, this one is another router, and there is one more router over here, just like this. Four routers are here. Okay, and this R5 is connected to one more router over here, just like this. Okay, let me connect all of them. Uh, area. It's fast Ethernet. Okay, FA. Just hold on for a second. Okay. So FA0/1 is connected with FA0/1. Here we have FA1/0, FA1/0. Okay. Okay. And this is connected to this side. Right or not? So we have a network like this, dear. And let us assume that on this side, we have configured, we have configured the area one. Which one? Area one. On this side, we have area one. Okay. This side, let us assume we have area zero. What? Area zero. This is area zero till here. Okay. Clear? Let me mention this. This is area one, and the next one is what? Area zero. What? Area zero on this side. Clear? Let me mention the network in between them, 192.168.10.0. Okay. 192.168.11.0. 192.168.12.0. And this one is 192.168.168.13.0. And let us assume the network in between these two is 200.0.0.0. Why I'm taking here 200.0.0.0? Because on these two R5 and R6 we are going to configure the BGP protocol to communicate in external network. Okay. So here we are going to configure the BGP protocol. Okay. Inside this is OSPF area 1 and area 0, whatever is that. Clear? Let me also provide the IP address. This is 192.168.10.1, 10.1. And this one is 192.168.10.2. Clear? 192.10.1, 10.2. Okay. Here we have an IP address 192.168.11.2 and 192.168.11.1. Okay. Let's move forward. Okay. On this side, we have an IP address 192.168.12.1, 192.168.12.2. Okay. Here we have 192.168.13.1 and 192.168.13.2. Okay. Here we do have an IP address on router number 5, that is 200.0.0.1, and on other side we have 200.0.0.2. Okay. The autonomous system for these two routers are different. Let us assume the AS number for this router is 100 And the AS number for this router is 200, right? AS number must be different to communicate. Okay. In BGP, basically, we can also do for the same AS number, but let's deal with the different AS. Okay. Now, let's start providing the IP address from router number 2. Okay. Turn on the routers. Okay. Router number 2, router number 1, router number 4, router number 5. Okay. And then router number 6. Now, first of all, let's start providing the IP address to router number 3. Here we have, okay, on router number 3, configuring terminal. Configuring terminal interface. Which interface is this? Let me click on view, show hide label interfaces. Okay. So this one is interface F0 slash 0 0 no shutdown. Okay. IP address is 192.168.11.1 and 255.255.255.255.0. Clear? On the next router, that is R2, will be one IP address. Okay. Let's go to R2 now. Okay. Configuring terminal interface F0 slash 1 no shutdown. IP address is what? 192.168.10.1 10.1 and 255.255.255.0. Clear? So now let's go to router number 1. Let's go to router number 1 and provide the IP address. Okay. So configuring terminal interface F0 F0 slash 0 no shutdown. IP address is what? 192.168.11.2 and 255.255.255.0. Okay. Interface F0 slash interface F0 slash 1 no shutdown. IP address is what? 192.168.10.2 and 255.255.255.0. Next interface is interface F1 slash 0 no shutdown. IP address is what? 192.168.12.0 12.1 and 255.255.255.0. Okay. Let's go to router number 4. Provide the IP addresses. Go to global configuration mode. Okay. Configure terminal interface F1 slash 0 no shutdown. IP address is what? 192.168.12.2 and 255.255.255.0. Next interface is interface F0 slash 0 no shutdown. IP address is what? 192.168.13.1 and 255.255.255.0. Okay. Next router is our router number 5. Let's do the configuration on R5. Configuring terminal interface F0 slash 0 no shutdown. IP address is what? 192.168.13.2 and 255.255.255.0. Okay. Next interface is what? Here we do have interface F0 slash 1. Okay. On router number 6, router number 5. So interface F0 slash 1 no shut. IP address is what? 192.168 sorry 200.0.0.1 and 255.255.255.0. Clear? Okay. Let's go to router number 6 now. Configuring terminal interface F1 slash 0 no shutdown. IP address is what 200.0.0.2 and 255.255.255.0. Now, dear, let me provide some loopback IP addresses over here. That is 192.16, sorry, 10.0.0.0.1, right? 10.0.1.1, 10.0.2.1, 10.0.3.1, 10.0.4.1. Okay. I'm just going to provide these loopback IP addresses. Okay. So let's go to router number 6. Provide the loopback interface. Interface loopback 1. IP address, which one 10 dot IP address is 10.0.0.1 and 255.255.255.0. Clear? Next is interface loopback 2. IP address is 10.0.1.1, okay, and 255.255. Interface loopback 3. IP address is IP address is 192.168 dot 10.0.2.1 and 255.255.255.0. Interface loopback 4. Okay. IP address 10.0.3.1 and so on. Okay. Interface loopback 5. IP address 10.0.5.1 and so on. Okay. Now, dear, do the configuration of let's do the configuration of OSPF over here, starting from R2. Okay. How we can do that? OSPF, router OSPF1 network 192.168.10.1 and 10.0 and 0.0.0.255 area 1. Right or not, dear? Hello?
Yes, sir. Right.
Okay, perfect. So let's go to next router R3 and we'll do the same. Router OSPF1 network 192.2.168.11.0 0.0.0.255 area 0. Clear? Okay. Let's go to router number 1 now. Okay. Router OSPF1 network
Sir,
192.168.
the
Yes, dear.
area zero or area one, sir.
Yeah, this is area 1 actually. Oh, sorry, we have done the mistake here. So, no worry. Only one network is available. We can do the configuration again. Router OSPF1 network area 1. Okay. Let's go to next one, router number 1. Okay. 192.168.10.0 0.255 area 1 on this side, right? Area 1 192.168.11.0 and areas 1. Clear? On right side we have another router. It will actually it will start creating the neighborship process with these two, right or not? We got the neighborship messages. Okay. So router OSPF1 network. This is 192.168.12.0 and 0.0.0.255 area 0. On right side, we have area 0 over here. So we are going to configure that part. Okay. Now, let's go to router number 4 and do the configuration. Okay. Router OSPF 1 network. Which one is this? 192.168.12.2 12.0 Okay. 0.0.0.255 area 0, right? And 192.168.13.0 and area 0. Okay. Let's go to router number 5, and also provide the network information. Let's advertise the network R5. Okay. Router OSPF 1 network 192.168.13.0. Okay. 0.0.0.255 area. Which area is this there? 0. Right or not? Okay. Now, let's advertise the next network. So, router BGP, which one? 100. Neighbor, which one is this? 200.0.0.2. Okay. Remote AS 200. Okay. Network is 200.0.0.0. Mask will be 255.255. In case of BGP, you have to provide the mask. Okay. Clear now? Now let's go to router number 6 and do the configuration. Okay. Router OSPF, router BGP, sorry. Router BGP 200, neighbor 200.0.0.1, remote AS 100. Okay. Network 200.0.0.0. Okay. And 200.0.0.0, mask will be 255.255.255.0. Okay. Next network is what? 10.0.0.0, and mask will be 255.255.255.0. Okay. Next network will be 10.0.1.0, mask will be this one. 10.0.2.0 to, okay, 10.0.3.0, okay, and 10.0.4.0. So we have just advertised all the networks over here, right? Now let's go to router number 3 and put a command, router number 3, and put a command, okay, show IP route. So here we got a table. Which one is this? Which one is this? If I talk about the directly connected network, that is 192.168.10.0, right? 11.0 is its own network. Okay. So within the same area, what are the routes available here? This one is within the same area, right or not? Hello?
Yes, sir.
Hello.
Yes, right.
And these two routes are coming from the intra area, from the different area, right? These are coming from the different area. But why there is no network from, why there is no network from this side? Hello.
Because in the router 6, you mentioned area 1. Sorry, our
Area.
area 1
No,
race.
no, no. Why there is no routes for the BGP protocol over here on router number 3? Because there's a process called redistribution that yet to be configured on R5. Because now we have to advertise both of these protocols. You have to advertise BGP protocol with the OSPF and OSPF with the BGP. This is called a redistribution process. Okay. Now advertise both of these protocol to each other. Okay. So for this one, go to R5. R5. Let's go to router number 5. Okay. Router OSPF 1. Okay. Redistribute BGP 100. Redistribute BGP 100 subnets. This command will advertise both of these protocol to each other. Okay. Now redistribute the OSPF in BGP. Redistribute. So go to BGP protocol router BGP 100. Okay. redistribute OSPF 1. Clear? After doing this redistribution, let's see will the route will be forwarded or not. Well, it will take some time to create the adjacency and forward the route. So just wait for some seconds. Okay. Okay. Got the routes from external or not, dear? Hello. Hello.
Yes, sir. Yes, sir. Yes,
Yeah.
external routes.
We got the routes from external on this side. That is 200.0.0.0. Right or not? We got the routes from this side also. Okay. Now, what the problem is this? We have some external routes. One was some from intra area, and this is coming from what? This is coming from what? External, right or not? I don't want to see in my table. I don't want to see these routes in my table. So what we will do? For this, I will have to configure the stub area to my non-backbone area. First of all, the rule says rule 1. What is the first rule? Rule number 1, that stub configured over stub configured over, where do we have to configure the stub? Non-backbone area. What? Non-backbone. We can do the configuration of stub over the non-backbone areas. Clear? Now let's go to this router number 2, router number 1 and router number 3, and do the configuration of stub area. How we can do that, dear? First of all, let's go to router number 3. This one, put a command configuring terminal. Okay. Router OSPF 1. Okay. Router OSPF 1 area 1 stub. This is the configuration for the stub area. Okay. So adjacency will be reset now. Let's go to router number 2, router number 1 also, and router number 2. Okay. So router OSPF 1, okay, area 1 stub, right? It will reset the adjacency now. Okay. Now let's go to router number 2. Okay. Router OSPF 1 area 1 stub. Okay. So adjacency will be forced to reset. Now let's check the routing table. Okay, dear. So as we have just seen that the router number 3 in the table of router number 3, let's observe show IP route. So we can see that the external routes will be converted to what? This one. Let me ping to router number 6. See what has happened. Ping 200.0.0.2. It is sending some bytes, okay, of the data. Okay. Okay. Let me ping to router number this one 200.0.0.1. So that is forwarded, right? 200.0.0.1. So let me check on router number 6. Is there any issue in the configuration or not? Router BGP 200. Ah, dear. This is router number 6, 200.0. So everything is perfect. 200.0.0.0 mask.
So the OSPF one you mentioned, router OSPF one.
No, that is another thing, dear. That's not belong to this one actually. Here is the configuration of router number 6. Okay. Let's check on router number 5. Any configuration issue? Hmm. Router BGP 100. Okay. And the network 200.0.0.2 remote AS 200. So everything is working perfectly. Let's check the redistribution process. Redistribute OSPF 1 in BGP 100. Yeah, that's perfect. Let me go to router number 4. See, is there any issue on this side also? Ping 200.0.0.2. Yeah, they are not pinging, right? They are not pinging. Let's see what has happened over here. Router OSP route distribution. So everything is okay, and we also getting the route from this network also, but router number. Let's go to router number 3, router number 2, and try to ping. Okay, 200.0.0.0. Yeah, we can able to ping this one. Okay, to this network, but there's any issue in between these two in pinging, right or not? We can able to reach the external route, right or not? We can able to reach 200.0.0.0, but cannot able to ping this one, right? Let's see what has happened over here. An issue with the IP address. Let's go to router number 6. Router number 6. Okay. Show IP interface brief. IP is okay, 200.0.0.2. Okay. Let me try to ping from R6 to others. Okay. Ping 192.168.13.0. Let's check the command for redistribution again. Go to R5. On R5, let's check how many networks are available. Show IP route. Yeah, in this one, we are not getting the route from the BGP, right or not? External route from the BGP in R5, basically. Okay, let's check configuring terminal. Okay, let me check again. Show IP route show IP BGP. This command. Okay, dear. So 200.0.0.0 is available, but there is no next hop declared over here. Okay. Configuring terminal. Okay. Router BGP. Which one is this? 100. Neighbor 192 sorry, 200.0.0.2. Okay. Remote AS 200. Right or not? Let me advertise this one and also advertise the network again. Network 200.0.0.0. Okay. And mask will be 255.255.255.0. Now let's see if there will be any detail or not. Show IP BGP. Yeah, there was no neighborship. If there was any neighborship, it will be disconnected. Okay. Let's see the IP address allotted over here. Okay. Let's go to router number 6 and do this again. Configuring terminal. No router BGP 200. Okay. So it will take some time to delete. Okay. Do show IP interface brief. Okay. IP is 200.0.0.1. That is okay. Interface is FA0/1. Okay. Now let's go to this one. To show IP interface brief. Oh dear, you got the issue? This is the issue here. Hello.
Yes, yes.
Yeah, this was the issue. The interface is FA0/1, but we assigned for FA1/0. Okay, let's change this one. Okay, so interface F0/1. Okay, IP address is 200.0.0.3, but it will not accept that. So we have to change the IP address for the previous interface also. Interface F1/0 IP address is 200.0.1.1, okay, and 255.255.255.0. Okay, let's change the interface IP F10/1. That was the issue actually, dear. No shutdown. Okay, IP address is 200.0.0.2 and 255.255.255.0. By mistake, we provided the IP address to F1/0. That's why it's not working. Okay, let's go to router number 5. Now let's distribute again do the configuration. Okay, router BGP 100 neighbor. Which one is the neighbor, dear? Neighbor 200.0.2.
200.0.0.2.
Yeah, 200.0.2 remote AS 200, right? 200 network is what? 200.0.0.0 and mask will be 255.255.255.0. Clear? Now let's go to router number 6 to the configuration router BGP 200 neighbor 200.0.0.1 remote AS 100. Clear? Network 200.0.0.0, right? And mask will be 255.255.255.0. Okay. Next network will be network 10.0.0.0 and mask will be 255.255.255.0, right? 10.0.1.0, 10.0.2.0, 10.0.3.0 and 10.0.4.0. Okay, dear. So we just provided the network over here. Now let's see how many routes are there in the table. Okay. Configuring terminal. Okay. Show IP route. Do show IP route. Okay. Here the routes are available, right? But still, we have to do the redistribution again. Okay. Let's redistribute, redistribute, uh, sorry, router OSPF 1, redistribute BGP 100 and subnets. Okay. Now let's do the same for second one also, router BGP 100 redistribute OSPF 1, right? Now we have just done the redistribution. Now let's check on router number 1 how many routes are available over here. Okay, on this one put a command to show IP route. Now we got the external routes or not, dear?
Yes, yes.
Yeah, we got the external routes. Okay, and in the stub area on R3 when I will put a command show IP route, you will find that there is no external routes coming here. Let me try to ping them. Ping, which one is this? 10.0.4.1. Okay, so this is okay. So they are not pinging. Let's see what's happen here. Okay, let's try to ping from R1. Will they ping or not? So, okay, ping 200 dot sorry, ping 10.0.1.1. Okay, so they are pinging, right or not? They are pinging, but it will block the external routes. Let's see, will this forward any data or not? No, it will not forward any data to that side, right? It will not forward any data to the external route. External routes will be completely blocked over here. Now let's see on R6, is the R6 pinging or not? Okay, ping 192 192.168.11.1. Yeah, that is pinging, but R3 cannot able to ping. Let's talk about R2. Okay, try to ping this. Ping 10.0.1.1. Yeah, that is pinging, dear. There may be any issue with this configuration. So all the routes can able to ping. Let's check on router number 3. What's happening over here? Yeah, they are pinging, right or not, dear? Hello,
Yes,
hello.
yes,
Yeah, they are pinging by the help of default route, but in their table there is no information of these networks, right or not? If I check on this, if I check the routing table of these routers by putting a command show IP route, so you will find that there is no information of these specific networks, but they are pinging, right? Because of what? Default route, right? Now the next problem is that we have the routes from the neighbor. We have the routes from this neighbor area. We have the routes from the neighbor area. Let's block these also. How we can block that? By the help of not so stubby area. What? Not so stubby area, right? Now how to configure this? Now let's go to router number 2, configuring terminal. Router OSPF, router OSPF1. Okay, area 1 stub. Okay, area 1 stub, and then the command is what? No summary. What? No summary. Stub, stub. No summary, right? No summary. This command is used to configure the not so total stubby area, right? Totally stubby area. Okay. Let's go to router number 3 and configure the same, configuring terminal. Okay, router OSPF 1. Okay, area 1 stub, no summary. Okay, now we have to configure on R1 also. Let's go to R1, configuring terminal. Okay, router OSPF 1, then area 1 stub, no summary. Now let's see what will be the impact of this. Okay, let's go to router number 3, check show IP route. Okay, so where is the other networks here? No, they're no longer available in the in the table. we got a table of three routes only, right? Hello,
Right, so right.
right? And now the next topic is what? Not so stubby areas. What? Not so stubby areas, right? Let us assume, dear, we also have one more area autonomous system bounded router over here also. On R3 also we have some external routes. On
Uh,
R3, yes dear.
so do we still able to ping the router 4 and router 5 from
Yes
router
dear. Yeah,
2
we
and
can
3?
able to ping. Yeah, we can able to ping. Let's go to router
Right.
number
Okay.
2. Yeah, let me ping. Which one? 192.168.13.0. Oh, sorry. We have to do this in privilege mode. Okay. Ping. Which one is this? 13.168.13.2. Yeah, they are pinging there because they have
So ping the
yeah.
loopback address as well.
Let me create a loopback address here, right? You want me to create a loopback address over here on area 0 or these loopback?
So these were the router 6 loopback.
Yeah, they are pinging. They are pinging the loopbacks. No worry. Let's go to router 1 and put a command ping 10.0.4.1.1. They are pinging.
Okay, okay. So, sir, we can ping the router, but the router table we will not get it,
Routing table
right?
will be shortened. Routing table will be
Okay,
shortened.
okay.
Yeah, this is the
So that
only.
that's the purpose of you. That's the
Yes,
purpose
dear.
of using Stubby.
Yeah, this is the only purpose of the stubby area.
Okay.
Now let us assume we are also connected R3 from the external routes. We have connected the R3 from the external routes. Okay. Let me connect one more network over here. This one. Okay. R7. Okay. In between them, let me configure. This one is FA is all 0/1, FA 0/1 over here. Okay. Let's provide first of all the network in between them. The network in between them is 192.16, sorry, any other network actually. 20.201.0.0.0 network is available here. Okay. 201.0.0.1 and 201.0.0.2 IP addresses are available here. Okay, dear. Now, let's do the configuration over here. Let us assume still on this side also we have the external routes. So for external routes, let's configure the BGP over here, router 3 and router number 7. Okay. So let's start with our router number 7. Okay. And let me also create some loopback IP addresses that is 11.0.0.1, 11.0.0.2, okay, 11.0.0.0.1 2.1, okay, 11.0.1.1, okay, 11.0.0.1, okay. Let's go to router number 7, configuring terminal router router BGP 1. Uh, Let us assume it's the part of BGP 150. Okay, they are in BGP 150, router BGP 150. Uh, I think we didn't have provide the IP address, right? Interface F0/1, no shutdown. IP address is what? 201, 201.0.0.0.2. Okay, and 255.255.255.0. Okay, interface loopback 1, IP address is 11.0.0.1 and 255.255.255.0. Okay. Next loopback is what? Interface loopback 2, and the IP address will be 11.0.1.1 and 255.255. Interface loopback 3, okay, and IP address will be 11.0.2.1 and so on. Okay. Let's provide the IP address to the router number 3 also. Okay. Configuring terminal. Interface. Which interface is this? F0/1. No shutdown. IP address is 201.0.0.1 and 255.255.255.255.0. Okay. Router BGP 150. Okay. Neighbor 201.0.0.2. Remote AS 300. Okay. Remote AS 300, and network is what? 201.0.0.0, and mask will be 255.255.255.0. Clear? Let's go to router number 7. Okay. Router BGP 300. Okay. Router BGP running as AS150. No. Router BGP 150. Okay. Router BGP 300. Okay. Neighbor 201.0.0.0.1. Okay. Remote AS 150. Clear? Network 201.0.0.0. Okay. Mask will be 255.255.255.0. Okay. Network 11.0.0.1 and 11.0.0.0 and 255.255.255.0. 11.0.0.0.255.
The default is subnet is different for 11.
Let me check. Uh, 11.0.0.0. Network. Okay, okay. We have to provide the mask here, dear. We have to mention the mask here. Okay. 11.0.1.0 and 11.0.2.0. Okay, dear. Now, if I will go to this router number 4, router number 4, let's see, is there any route available from this side or not? Okay. Configuring show IP route. So, is there any routes available or not here from this side? We are getting the routes or from this side or not, dear? No, we are not
No,
getting
sir,
any
no.
routes, right or not? Why? Because we didn't have configured the redistribution over R3. Okay. So router OSPF 1. Okay. Redistribute, redistribute, redistribute. Which one? BGP, BGP 150 subnets. Clear? Now let's go to what? The router BGP 150. Okay. Redistribute redistribute OSPF1. Now we've just done the redistribution over here. Okay. Let's go to router number 3. Put a command show IP route. So will you have you found all the networks from the BGP? Hello.
Yes, sir. Yes.
Okay. If I go to router number 4, show IP, show IP route. So the information from the 192.168.10.0 will be blocked. Let's go to router number 2. See, any information is available or not. Router number 2, show IP route. Okay. Any information available here? No information is available here, right or not, from any external routes, right? Now, how to pass this information to others? How to pass this information to others? How to pass this information to others? By doing the configuration of not so stubby area. What? Not so stubby area. These information will be converted to a special type of route that is called NSSA route. Okay, that will be converted to NSSA route and will be forwarded to other areas now. Okay, let's do the configuration of for the same. Okay, how we can do that, dear? Configuring terminal router OSPF 1. Okay, area 1, then NSSA. What? Area 1, NSSA. Okay, but it is saying that before before going to configure the NSSA, you have to remove the previous configuration for the that you have configured in what? Stub area, right? That we have configured in stub area. So how we can do that? We have multiple options for that. First one, we can reset the OSPF process, right? Clear the OSPF details. We can put a command no router OSPF1 that will be completely deleted, right or not?
Yes, sir. Yes.
Right? We have that part. We can remove the complete protocol, right or not?
Yes.
But but let's see, we have other part also to do that. What? Because we can't reconfigure everything. Okay. So what we will do, we will go to the router OSPF 1. Okay. Router OSPF 1. No area 1, then stub. No area 1 stub. This is the configuration used. Okay. It will be forced to reset the neighborship. Let me delete on R3 as well. Okay. Configuring terminal. Okay. Router OSPF 1. Okay. Then the command will be no area 1 stub. Okay. Let's go to router number 1 now and we'll do the same configuration. Configuring terminal. Router OSPF 1. No, no area 1 stub. That's it. When I will delete the configuration of stub area and we'll check the configuration on any router. Let's go to router number 2, put a command. Which command? Show IP route. Now the table will be really bigger, right? All the routes are available here. From this side and this side, all the routes are available here. Now we will do the configuration of Next one. Okay. Router OSPF 1, area 1, area 1, NSS. That's it. Okay. Area 1, NSSA. Let's go to router number 3. Okay. Router OSPF 1. Okay. Area 1, area 1, NSSA. Okay. Now let's go to router number 1 again. Okay. Router OSPF 1, area 1, stub. Sorry, area 1, router OSPF 1. Okay. No, area 1, stub. Area 1, NSSA. Okay. Now everything has been done. Now let's go to the configuration show IP route. Okay, dear. So all the routes, let's check on R1. Let's go to the R2, put a command. What? Show IP route. So here you can see the O and here, right or not? O and N here, right or not, dear? O and 2, O and 2, right?
Yes, sir. Yes.
So all the external routes will be converted into special type of route that is called ON2, right? So this is called not so stubby area configuration. Any confusion with this, dear? Dear?
Sir, here the we don't have a information of the router 6 in the router 2 table.
Yeah, let's see if they can ping or not. If I will try to ping 10.0.1.1. Yeah. So we can not able to ping this part now, right? That is all. That is completely blocked over here, and only we can pass the. We can able to pass the. We can able to pass the external routes from here. Okay. And if I will do the configuration of total stub, uh, then these routes will also be what blocked over here, right?
R6 is already
But
blocked in
dear,
the
let me tell,
NSSA.
yeah, let me tell you that why we use this. That I just want to pass this information. I just want to pass this information without disturbance, right? I don't want that will these networks, this one or this one, will do any communication on this area. I want to block, I want to block external routes as well as intra routes to be communicate on this side, right? What I will do, and I also want to pass this information to this side. That is mean they can able to forward the data, but this will not be disturbed. So for that, this information will be forwarded on the behalf of ON2, special type of packet that is called not so stubby area packet actually. Now this will completely block the LSA 5 but will receive the data from this side. Now what has happened if we will do the configuration of totally NSSA? What will be blocked in this scenario? Okay, let's do the configuration now and we'll see what will happen. Okay, configuring terminal router OSPF 1. Okay, router OSPF 1. ABR will inject the will not able to forward the any of these LSAs from the outside, but the LSA from the router 7 will be forwarded. Okay. Okay. Let's do the configuration for the same. Router OSPF 1. Okay. Router OSPF 1. Area 1. Okay. NSSA. No summary. No, no summary. Right? Let's do the configuration on R2. Let's do on R1. Okay. Configuring terminal. Router OSPF 1. Area 1. Okay. Area 1. NSSA. No summary. Okay. Let's go on router number 3. We'll also do the same. Router OSPF 1. No summary. Okay. Now let's see what are the details in the table. Show IP route. So everything has been blocked over here. Okay. And now the inter area external routes will be converted into O star IA. Right or not, dear? Let me try to ping any of these. Okay. Ping 10.0.1.1. Yeah, they are pinging now. Clear, dear? They are pinging. Let me check the table. Show IP route. Show IP route. So all the routes will be converted into what? The special type of what? External external LSA, that is called NSSA. Right or not? 10.0 and 11.0 is available, but external routes like 13.0 will be converted to default route. Now any confusion, dear? This is just to pass the information of this external route by the help of what? NSSA. Okay. Now any confusion with this, dear?
Sir, we'll get to this, then we'll let you know next class.
Sure.
The last actually little confusing, but we'll let you know in next class, sir.
Sure, dear. And dear, the issue is that I think during the session, when there was a disturbance in the network, I think the recording of first is was not done. So I will record. I will check in other class if that will be available. Available, I will forward you. Okay. Let me cross check over there.
Okay, so okay.
Okay.
So, main we have four types: the stub area
Stub area, total stub,
and
not
uh,
so stub
and
area,
totally
total NSSA.
totally stub. Okay.
Okay. I will forward you the
Stub
recording.
area,
Yes, dear.
yes.
Can
Stub
I?
area, totally stub, NSS.
Yeah,
Yes.
NSSA and totally NSSA.